Baik, kali ini kita belajar yang namanya Anova atau Analysis of Varian. Jadi di sini menganalisis apa itu varian dengan membandingkan nilai rata-rata sepanjang berbagai populasi. Anova adalah sebuah uji hipotesis, ya, pendekatan uji hipotesis untuk menguji apakah equality of mean, apakah mean sepanjang populasi itu adalah sama. It is an extension of G-test and T-test which only test for equality of means between two population. Ini adalah lanjutan dari uji Z dan uji T, di mana hanya menguji rata-rata antara dua populasi. Jadi Anova itu bisa lebih banyak populasinya. Anova menanyakan perbedaan rata-rata sampel dari berbagai variabel acak yang datang dari populasi yang sama, ataupun setidaknya satu rata-rata sampel yang datang dari sebuah populasi yang berbeda. Tes statistik digunakan untuk menguji hipotesis ini disebut F-statistik atau uji F. Perbedaan signifikan antara rata-rata sampel ditemukan terjadi, diasumsikan untuk menjadi faktor yang mempengaruhi dari faktor yang memberi kesempatan. Bab ini akan mempertimbangkan kasus satu faktor yang mempengaruhi dari berbagai rata-rata sampel yang berbeda, sehingga dikenal sebagai one factor Anova, digunakan untuk menguji berbagai perbedaan rata-rata. Setelah belajar bab ini, kita akan mampu mengidentifikasikan kapan mengaplikasikan Anova untuk sebuah teknik uji hipotesis. Kedua, memahami rasional dari Anova dan bagaimana menguji untuk rata-rata persamaan rata-ratanya. Ketiga, menghitung F-statistik untuk satu Anova, soal satu Anova. Keempat, menginterpretasikan penemuan tentang Anova, aplikasi dari Anova. Introduction to the concept Anova. In chapter 10, hypothesis test for the difference between two population mean was conducted using either Z or T-test statistic. However, when more than two population means are compared for equality, a different test statistic known as the F-statistic is used. The test procedures is used to compute F-statistic is called analysis of variance. In many management areas, there is a need to compare the mean of a numeric random variable across multiple population. Illustration: does average fuel consumption vary across 5 different makes of 1,600 cc cars? Is the average hourly output of item the same between 4 models of the same machine? Is there a difference in the mean annual return between 3 types of unit thrust? In each illustration, a numeric response of variable, example fuel consumption, machine output, annual return, is observed under different condition. Example: different makes of car, different models of machine, different unit thrust, called a factor, which the types of condition called factor levels or treatment. To illustrate unit trust category is the factor, and the three category types are factor level. Each factor level represents separate sample. The purpose of ANOVA is to determine whether there is a statistical relationship between the factor and the response variable. Are the two measures statistically dependent or not? Comparing sample mean does this. If at least one factor level, sample mean can be shown to be different to the other factor level sample mean, then a statistical relationship has been found between the factor and the response variable. If, on the other hand, sample means are not significantly different, then it can be concluded that the factor has no influence on the outcome of the response variable, that the two measures are statistically independent of each other. No statistical relationship. This implies that any observed difference in sample means are due purely to change and all the sample data was actually drawn from one homogeneous population. Analysis factor of variance. One factor analysis variance. One factor ANOVA. This chapter will only consider the influence of one factor. Example, unit trust, machine type, make of car, to explain the difference in sample means. This analysis called one factor ANOVA, and its rationale will be explained through work example. Since ANOVA is an inferential hypothesis testing technique, it follows the same 5 steps of hypothesis testing as outlined in earlier hypothesis tests. Example, unit trust return study. A financial analysis studied the annual return of 3 different categories of unit trust. She wants to know whether the average annual return per category varied across unit categories. A random sample of unit trust from each of 3 categories, labeled A, B, and C, were selected, and their annual return were recorded. The data is shown in table 11.1. Sample, this is the data. Sample data of unit trust annual return. Unit trust A. This is unit trust A. Unit trust B. Unit trust C. Okay. Management questions. Can the financial analysis conclude that the average annual return from the 3 category of unit trust are the same? Conduct a hypothesis test at the 5% significant level. Solution. The response variable is the annual return of the unit trust. Each sample in table 11.1 represents separate category of unit trust and collectively is called the factor in this study. The purpose of ANOVA is to find out if the annual return of unit trust are influenced by the category of unit trust. There is no influence of unit trust category on annual return if the population mean annual return can be shown to be equal across all 3 categories. Exploratory data analysis. Table 11.2 shows example annual return across 3 unit categories. By inspection, category C unit trust appear to have the highest average annual return, 12.8. Which category B has the lowest average annual return, 9.5. Descriptive unit statistic for unit trust annual return study. Unit trust A, B, C. N. A is 6, B is 4, C is 5. Sum 63, 3864. Average is 10. Average is 10.5, standard deviation is 2.74. Now let's practice this. How do they get the average and how do they get standard deviation? This is a C. Data in Excel we can make this into a more what we call easier way without doing some mathematical. Descriptive statistic, we choose descriptive statistic. First, we open data analysis. Data analysis, and then descriptive statistic, okay. And then input range. We input the range of the data. Enter output range. Enter, and then summary statistic. Okay. Because there is a non-numeric data, so we just now we have seen column 1, column 2, column 3. So this one is the standard deviation for column 1, that is A. Or we can change this into A, this one B, this is C. So we have the standard deviation. We can see standard deviation is 2.73 or 2.74 for A. this one is the, yeah, this is the 2.74. Yeah, let's check out for sum. Sum is total. Total, okay, we can see on the Excel is this one. A, this one. Sum 63. And then average or mean. Average or mean 10.5 for A. And then this is for A. Standard deviation is 2.74, this one. For B, N is 4. N, yeah, this is count. Okay. And then sum 38, this one. Average 9.5. Standard deviation 2.65. For C, N is 5. Yeah, C is 5. And then for sum is 64. And then for average 12.8. Standard deviation 2.39. Yeah, so we have count all the data statistic that we need. Now, the management questions that needs to be addressed through a hypothesis test is whether observed difference in sample means are small enough to be attributed or large enough to be due to the influence of the factor or the different unit trust categories. To conduct a hypothesis test of equality of means, the Anova approach is used. There are 5 steps in doing hypothesis tests. Step 1, define null hypothesis and alternative hypothesis. Null hypothesis is always states that all the population means are equal. Thus, H null mu1 is mu2, mu3. H1, at least one mu differ. I is 1 to 3. At least one unit category has different mean and will return to the test. Note that alternative hypothesis only state that at least one of the population mean must be different. It does not imply that they must all differ from one another before H null is rejected. If H null is accepted, this implies that annual unit trust return are independent of the category of unit trust. Alternatively, if at least one sample mean is found to be significantly different to the rest, then it can be concluded that the mean annual return do differ by unit category, and H null is rejected. Step 2, determine the region of acceptance of the null hypothesis. The Anova test is based on the F distribution, as shown in figure 11.1. This hypothesis test is always an upper tail test with a single cut-off point between the region of the acceptance and the region of rejection of the null hypothesis. Or we can say F crit. Yeah. Now look at the picture. F distribution. This is F values. This is the middle. And then this is F acceptance. This is F region. Showing the region acceptance and region of rejection. Okay, now we continue. To find F crit both level of significance, alpha, the degree of freedom must be known. For this example, the level of significance is given as alpha 0.05. There are two values of degree of freedom of an F statistic. They are called numerator degrees of freedom and denominator degrees of freedom. Numerator degrees of freedom is df1 is k minus 1, where k number of samples or factor levels. The denominator degrees of freedom df2 n minus k, where k is number of samples or vector levels, n is total combined sample size. So the critical F value is defined as F alpha plus times k minus 1 n minus k. In the example, k is 3 samples, n is 15 data. So degrees of freedom is 3 minus 1, 15 minus 3, or 212. The F critical limit is read of table 4 in appendix 1. To read the F table, select the table for alpha 0.05. Identify the column for numerators degrees of freedom and the row denominator degrees of freedom. The values of the intersection of the row and column is called F critical statistic. Thus, F 0.05 212 is 3.89. Now let's look at how they find it in the table of F statistic. Usually, we can find the F statistic table is on the last page. First, we must copy the 281. We must copy the degree of freedom. Yeah, this is the F table. You can find it in your book on page 451. This is a F distribution with alpha 0.01, or we can say this is the F table for 1%. In the problem, it said that the is 5%. F distribution for 5%. Okay, this one. F distribution with alpha 5%. Now let's look at the problem here. 3, this one is degree of freedom. 2, 12. 2, 12. Now we look at the table. 2, 12. Degree of freedom of numerator and degree of freedom denominator. Numerator we can say in the bahasa pembilang. Denominator is penyebut. Now we can look at how we check it on the table. Select, identify the column numerator degree of freedom and denominator degree of freedom. This is a denominator, or we can say this is X. This is numerator. Now, the next step, the value at the intersection of the row and a column is the value of F, critical F value. Now, the value is 2, 12. Yeah, this one, this also F distribution with alpha 0.05. 2. This one is 2. 12. The intersection between 2 and 12, that's the critical F value. So we get 3.89. That is for F critical value. Now let's go back to the page of our lesson, page 281. Now we have that 3.89, hence the region of acceptance is H0 is F lower or equal than 3.89. The decision rule is that stated as follow: accept H0 if F statistic lies or at below the upper limit 3.89. Reject H0 if the F statistic lies above 3.89. This means if we draw a straight line, 3.89 is in the middle. Whether the next F calculation on the left side or the right side. If it is on the left side, it is lower than. On the right side, it is higher than. Okay. Now, we know the F's critical value of, we can say in the bahasa, people say that F tabel. Now, we want to calculate the sample statistic, or in the bahasa F hitung. Appropriate sample test statistic or F stat, unlike the two sample mean tests, which compare the sample means directly using either Z or T. ANOVA test compare sample mean by examining within or between different sample. Constructing the F-test statistic using ANOVA. The F-stat sample test statistic is calculated in 3 stages based on sources of variability within the total sample data. Variability is measured how far data values lies from the mean, and based on the concept of standard deviation is called sum of square. Stage 1, deriving sum of square. ANOVA identifies 3 sources of variability in the total sample data. Total sample variability, or we can say sum square total. Between sample or between treatment variability, we can say sum of square total. And within sample variability is SSE or sum square error. Total sample variability, SST. To calculate SST, first combine all different samples into one overall sample and calculate the grand mean. Okay, you can see here on the mean usually like this one. Mean is in the bahasa rata-rata. Usually we draw X and then there is a single line that is mean for usual mean, rata-rata biasa. If there are two lines above the X, it represent total means, rata-rata total. Now we continue. Calculate it as follows. X, each individual data value across all the samples, and the combined sample size. Look at this one, double sigma X. It means sum of all data values across all the samples. Then the overall grand mean. This is what grand mean. Yeah. So we can calculate grand mean is, there are 2 sigma. So it means total across the samples divided by n, population. Now let's look at the example. Now calculate a measure of deviation or variability of each value X from the overall grand mean. When these deviations are summed, the result total sample variability is called total sum of square. Look at the formula. Total sum square, 2 sigmas or double sigma, X mean minus grand mean, and then powered by 2. Okay. Now look at the example. In the example, sum square total is 108, which derive from formula 11.2 and formula 11.3 as follows. Now, how do they get 108? Let's look at our example again in Excel. So we know the total value. Look, they want to count. There are, if you look at carefully, here you can see there are two sigma. Sigma means total. Now, it means here we want to make the total. This is our data. These are our data. We want to make the sigma, double sigma. You can see in Excel here, there is a function too, how we make a double sigma. Okay? Here. Open home. And then you can see a sigma sign. Now we just press it. Sigma. Enter. And then we go here. Sigma. Enter. Oh, nope. Yeah. And then we want to find the double sigma. The double sigma is the total of all the sigma. Yeah. 165. Let's check out the problem. How much? Yeah. Double sigma, we can see here 165. And then we want to know n. In statistic, you must remember that there is a difference. A capital letter of n, it means from population. If it is small letter, it means from sample. So if we look at the here, this is a capital N. Yeah, capital N. So it means total of the population. The total of population we can calculate in Excel. Yeah, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So we have N is 15. Yeah. Same as like this one. And then we want to find the grand mean. Grand mean is found by divided double sigma divided by all the population. We have count that double sigma is 165 and the n is 15. So we have the grand mean is 11. Now, we want to count the sum of square. This is actually how we do it step by step if we do it manually. But if we want to do it in Excel, it is very easy, like this one. We can calculate it in one step, but we must know first how to do it manually. And then we want to count sum square total. Sum square total, the formula is double sigma x minus grand mean squared. Now, look at here, sum square total. Yeah, okay. Here, it is started. Here is the data. Okay. we want to make it a better table. Now, this is what we call data. Okay. And then we copy it all here. Copy. Paste. And then we copy this one. Yeah, we will look how we do it in Excel, but we do it manually. Okay, here is the data. We want to count X minus grand mean. Okay. So we make in the table X minus grand mean. Enter. Grand mean is 160. Grand mean is no 11. Grand mean is 11. So data mean we have X minus 11. Enter. Yeah. Yeah. Okay. And then we drag it to the bottom. Now, the formula show that it must be squared. So we have copy this one and then this one. Yeah. And then we make this one quadrat. Then we count it by this one times this one. Enter. So we drag the formula. These are the X minus grand mean squared. And then look at the formula again. It says here double sigma. Okay, so we calculate the sigma. One hundred eight. Yeah. 108, and then the next step is to find between sample variability or SST between treatment. Calculate the deviation or variability between each sample or treatment. Mean and overall grand mean. The extent to which sample mean deviate about the overall grand mean. Explain the influence of factor level. Category of unit trust. This measure of variability is called between treatment sum square or SST. The formula for SST is sigma from K to J and J times mean J minus mean double mean or grand mean squared. Now, where n is sample size of J sample or treatment, X bar or mean is sample mean, K is number of different sample or treatment. In the sample SST is 26.7, which derived using formula. Okay, 10.5 minus 11. Yeah, okay. So, how we find this one? How we find the SST? Now, look at here in the Excel. I will show you how we find it. We must use this one, because treatment A, treatment B, treatment C, we want to find each of the following mean. For treatment A, we see here, this is the mean, 10.5. Treatment B is 9.5. If we look at the formula again, the formula now, we want to find the mean. This is the grand mean. Mean is here. We can look here, mean for each of the treatment. All of these are mean. This one, mean A, mean B, mean C. This is just mean. We have calculated the grand mean already. That is 11. So, from this one, we want to calculate. Okay. This is mean. This is treatment. A, B, C. This is mean. This is grand mean. Enter. Now what we need again? Oh, squared. Squared of grand mean. Oh, mean minus grand mean. Enter. And then we copy here, paste, and then we can say it here quadrat or squared. Now, we have known that the mean of each treatment. Number 1, 10.5, 9.5. 9.5. And then treatment C is the mean, 12.8. Yeah, this one, 12.8. Grand mean, as we know that before, we have count the grand mean for all is 11. Yeah, grand mean is 11. So 11 okay, mean minus grand mean then we drag it and then squared. Yeah, these are the values. Now look at the formula. We have calculated this one. This one already calculated. We need n because sigma n times x bar minus double x bar squared. Okay, now yeah, and then we calculate this with each what we call samples n. For A is treatment A. Treatment A, how many? How many we find here? Treatment A, 1, 2, 3, 4, 5, 6. That's a treatment A. So we make it here 6. Yeah, look at B, treatment B. Look at here. B is 1, 2, 3, 4. Then we for C 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5. Okay. From the formula we see here each of the treatment, yeah, we multiply with each n, each sample. Okay, and then n times, or in the bahasa I will write it down, n kali kuadrat we copy this one. Yes, copy, and then here face. Okay, we changed it into n kali, enter, and then we calculate it. Then we drag it. Yeah, that is, we find the formula for SST until this one. Now we look at here, there is a sigma Sigma means total. So we calculate it to find the total. Sum. Enter. So we have SST 26.7. Yeah, that's how you find the SST, or total variability of 108. Now, within error sample variability, or SSE, SSE is count using this formula, SSE. Yeah. Well, if we look at carefully, the difference is this one. Only one X bar. Yeah. SST is double X bar. SXT is X minus double X bar. X bar here. But for SSE only X minus X bar. So here the most important thing is just regular mean. Yeah. Now we look at the example. In example SSE 81.3, which derive as followed. Now, here we need for, yeah, this is the data. Mean A, treatment A is 10.5. Okay, I think we copy this one and then make it into appropriate. Yeah, here. And then we copy it and make it smaller. Yeah, this one. Treatment A, treatment B, treatment C. Now we copy this formula so we don't have to look back and forth. This one, copy. Now we do it in Excel. First, we must find the value of X minus X bar. Okay. So we can say we must do it, I think, step by step. Look at the formula. Yeah, only each of the following. Yeah, this one. Each treatment. So we make this X minus X bar for A. Enter. Yeah. And then we no. Let's this one. Mean A. So is the same as here divided by 6. No, what happened? Why? Oh, no. Ya. Mean B. Mean C. The formula is to find each minus from its mean. Now we look at the Excel here. A minus mean A. So here yeah. Yeah, and then B minus mean B. Here minus 9.5. Yeah, okay. And then we must find the C minus yeah. Okay. Look at here. Here each we have done this, but we haven't done this. This to square each of it. Okay, now we want to square. Yeah, we write this quadrat minus, and then we make this one mean A times enter, and then we drag it. B, and then we change this into quadrat enter, then we drag it, then we change this, enter, yeah. Now we check it. We have finished this. The last step is double sigma. Double sigma mean grand total. Now we calculate the grand total. So here we write sum. Enter. Here we write sum. Enter. Here sum. Enter. Now we want to find double sigma. So this one plus this one plus this one. Enter. 81.3. Let's check it out. Yeah, the answer is sum SSE is 81.3. Same. Now let's do it. Let's continue again. SSE value 81.3 measure the amount of variation within each sample and sum across all sample, those that cannot be explained by the factor. Since its explained represent unexplained variation, it is called error sum square. But in the bahasa usually we read this with sum square error. Okay. Now we want to find sum square principle, or we can say SST total is SST sum square T, yeah, and then SSE. This show that the square are additive. Total sample variation between sample variation plus within sample variation, or total sum square, explained sum square, and unexplained sum square. Yeah, okay. See, I want you to remind that total is the addition between explained and plus unexplained, or in other word, total sample variation is between plus within. Okay, it is the same like this. Okay, tot sum var is between plus within. Oh, in the bahasa antara ditambah yang di dalam. Tot sum, it is the same. Square is explain plus unexplained. Ya, yang bisa diterangkan tambah dengan yang tidak bisa diterangkan. In other words, how to find this? You must remember this one, ya, ya, this is sigma x bar minus x double bar. Remember that one, times n. This one, oh no, yeah. No. Let me yeah, okay. S as sum square total total sum square is explain plus unexplained. For explain you must remember, you must remember the formula. The difference between this formula, this one. Look how easy it is if you pay attention. But if you don't pay attention, it's very difficult for you. For explain or with between, you must remember. Explain is, in other words, is the same as between. And then unexplained is the same as within. Pay attention, look at the formula, how easy it is actually if you do it by yourself. Compare these two formulas. How do you memorize it in a very simple way? I will call one person, one student, to explain to me how you explain it. Because if you don't memorize it, it is impossible you find the answer. What's the difference between and within? Explain and unexplained. Please, Melissa Jarifa. Mutia Jahara. Who is Mutia Jahara? How do you make it or explain it in a very simple way? The difference between this. Ananda Pertiwi. How? What is the difference between these two formulas? Gigi. Okay, not complete. Danis Randi. Who is Danis Randi? Explain. There's one. Yes. Dini. What is your explanation? To make it as very simple, a short simple, so you can memorize it in the test later. Yes. Okay. Okay. Nice try. Franciscus. Yes. I want you to explain it in your own language, so you can understand later on. Actually, Anova is not very difficult, after you find this one, after we have made a long explanation, yeah, I think more than 1 hour already. So you make the conclusion. What we are studying, and then the conclusion is this one in your own language. Franciscus? Yeah, okay. Dini? You already, right? Okay. Genevieve. Yes. Okay. Grace. Yeah, Grace. That is very long, but nice try. Weni Putra. Yes. Make it short. You want to explain our lesson to SD students. Okay. Pira Dwi Amputra. Ya. Okay. Stefana. Yes.
Kalau di sampel treatmentnya Pak, di sigma itu terdapat hanya satu sampel minnya saja Pak. Tapi jika di error sum of squares-nya itu
Yeah. Now I will repeat it again. After we find within and between, or SST and SSE, we want to find the sum square total. Now, first we must find mean square total. That is sum square total divided by n minus 1. N is n1, n2, n3, 6, 4, 5. So it is 15 minus 1. So it is 14. Sum total is 108. The F14 and in the here we calculate this 108, n is 15 minus 1 14, 108 per 14, so we have 7.71. Let's check it on Excel. We check it on Excel. Here 108 divided by 14. 7.71. Now, let's look at again. That is mean square total. Now, the next step is called between group variant or MST. Look class, there is a difference here. Here, how we write it, the book write this. MS total, it is for mean square total. MST is called mean square treatment. You must look here. This is total. This is just no total, just T. Different is, look at here, SS total. This is SST. This is N, but here K minus 1. Okay? Now, look at here. And then we find the mean square treatment. Mean square treatment. After that, we find the mean square error. Mean square error, sum square error per N minus K. Okay. The last one is F statistic. F statistic, it is in the bahasa, it is called F hitung. Is division of MST. MST is mean square. What is MST? MST, this one. Mean square. Mean square treatment. Divided by mean square error. Now, we want to do this in Excel. First, data. We show data. And then data analysis. What happened? Here. We data. I don't know what happened. Okay. Something wrong, I think, with the Excel. Hang. Data analysis. And then we choose single factor Anova. Okay. And then we choose the data. Enter. And then label in first row alpha 0.05. Output range. Enter. Okay. We wait because my laptop is not a very good laptop. This is a cheap laptop. Okay. We wait until the result showed. here. Why it is so? Yeah, here it is. Here we can see here from the result of the, we make it bigger, so you can read it. Between group, within group, sum square, this one, df, this one, mean square, this one, f, this, f statistic is 1.971. Why is it different? This one is the 13, 971. F is 1 point. Why? What happened? Okay, let's do it again, but now we want to make the another ANOVA. Oh, no, wait. Our title is ANOVA with different ANOVA is between mean. Oh, not one factor. Okay, now we choose one factor with. Okay, now input range. Let's look here. Enter. Alpha. Output range. Let's here. Okay, enter. Okay. Row per sample is required. Per sample row. Oh, yeah, cannot be with replication. Okay, we cancel this one. Enter. Okay. Oh, why it is non-numeric? Enter. Input range contain non-numeric data. Okay, wait a second. I don't know why it is different, from Excel. Now let's look at the title. That ANOVA is multiple across multiple population. Okay, let's copy this. We pause it first. Yeah, okay, we data analysis single factor. Okay, we cancel. Okay, we must arrange this into one row. This is the data. Right, after we arranged it into one row, data analysis, okay, input range, this one, we make this one into the data, one row, one column. Okay, two or more block of data arranged in row or column. Two or more. Okay. Why? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Output, enter. Wait here. Yeah. Same. No difference at all. F critical. Yeah. Here, look, there is an exercise how to do it in Excel. If you look at the book, yeah, here, how to do this in Excel, there is a, using Excel, single factor ANOVA. Yeah, we have done this. Add in Excel, yeah, Excel FinF, okay, output. Oh, yes, if we do it in Excel, the same result. Yeah, this one, yeah, between group 26.7, 12.5, within group 70. What? Count 63, 5. Yeah, I think there is something wrong, not with me, not with the Excel, yeah, but I think the data. Let's check the data. I think there is something wrong, yeah. Now we look at the data. First data. Here is the data. Copy it, and then let's check it. Eleven, 7, 14, 9, 10, 13, 6, 8, 11, 12, 13, 16, 14, 10, 11. It's correct. Why? Yeah. Okay. Last time. This one I will not do it again if it is give the wrong answer. Okay. The book said one single factor. Okay, let's do it slowly. You Excel. Oh, Excel 2007. My Excel is 2013. Yeah, my Excel is 2013. This is how you do it in Excel 2007. I think almost the same. Okay, let's I will do it again. Okay. Data analysis Anova single factor. Okay. In Google, we see that this is almost the same. Yeah. Here. This is using let's do it again here. Column. Okay. Here. Yeah, still the same result. Yeah, we in Excel Now let's check it on Google. Google is the same too here. Yeah, single factor. Okay, let's look at the Google here. Data. Oh no. How one way Anova. Okay. Yeah, okay. That's how you do it, yeah. The manual and with help of Excel. Now read the summary and then answer the question. Yeah, answer the question using Excel or manual. Yeah, you can send this your answer tomorrow morning at 8 o'clock. Yeah, that's it for today. Thank you. Exercise. Look at your book.